Okay, all right, we're ready to get started now. So, good morning, everybody. You know, it's great, as I said earlier, it's great to see all of you here today on a rainy day that you all came out for this special opportunity. And as you can see, we have two special guests with us, Senator Mikulski and Administrator Bolden. They've been obviously great supporters of NASA. And today we'll be talking about JWST, and they've been great supporters of the James Webb Space Telescope. Before we get into the James Webb portion, though, I would like to mention that 2013 was an incredible year for NASA and the Goddard Space Flight Center. So we're extremely pleased to have Senator Mikulski and Administrator Bolden here to help acknowledge some of these accomplishments. And already this year, we've had two great accomplishments. We launched TDRS. It's on the way to geosynchronous orbit. Everything is going well. We had a sounding rocket launch campaign at Wallops. And I see Bill standing in the back, and we're still waiting to launch one from Kodiak to look at the Aurora Borealis. So it's been a very, very busy year already. And later on this month, we'll be launching GPM from Tanegashima in Japan. However, we can't spend all of our time talking about the outstanding accomplishments that marked 2013 and the beginning part of this year. We do want to take this opportunity, though, to note the significant year that JWST had in 2013 and the beginning of 2014. Most of the hardware, all the critical hardware is here now for the James Webb Space Telescope to begin testing. We just recently completed at Northrop Grumman the critical design review for the spacecraft, and today you're going to have the opportunity to see some of that hardware. I'd like to take a moment to acknowledge some of our special guests that are sitting in the front row, and I would ask that you hold your applause until after I've introduced everybody. Okay. All right, I don't know how to follow that, but at any rate, we'll try. Okay, sitting right here in the front is Dr. John Grunsfeld. He's the Associate Administrator for the Science Mission Directorate. Next to him is Eric Smith, the Acting JWST Program Director and the Program Scientist. Sitting next to him is John Mather, the Project Scientist, Senior Project Scientist for JWST and our Nobel Prize winner. Next to him is Bill Oakes, the JWST Project Manager. And next to him is Matt Mountain, the Director of the Space Telescope Science Institute. And next to him is Bill Smith, the, what are you, President of the Association of University for Research in Astronomy. Sorry about that. Let's see, my thing is out of order now. So I have Rob Strain, the President of Ball Aerospace, and many of you may know him. He used to stand up here where I am. We have Wanda Segur, who is the Vice President and Deputy for Civil Space at Lockheed Martin Space Systems Company. We have Bill Mackey from the Canadian Space Agency, Marco Siriani of the JWST Science Operation Development Manager of the European Space Agency, and we have, I apologize, Charles Atkinson, Director of the JWST Optical Telescope Element from Northrop Grumman. So if you could give them a round of applause. Trust me, without their leadership, we wouldn't be here today. They have taken JWST from, in some cases, from the beginning, like John and Eric, and in others since we had that little hiccup a while back, and brought it to a really great state that it is today. So now we have a video that is going to run to give you an idea of what the James Webb Space Telescope is doing. There's no need to stand up. So James Webb is the follow-on to the Hubble Space Telescope. It's going to allow us to see back in time in the formation of the universe when the first stars and galaxies began to form. It's also an incredibly technical and complex machine. You can see some of the hardware as it's coming in. The instruments are located behind a tennis court-sized sun shield that shields the instruments from the sun. And then it operates at 50 Kelvin or minus 390 degrees Fahrenheit. To give an idea of that, that's colder than the liquid hydrogen in our most sophisticated rockets that we use. It has 18 beryllium mirror segments that work together to form a single mirror, 6.5 meters in diameter. That's more than 7 times the area of Hubble's 2.4 meter diameter mirror. As I mentioned earlier, last year marked an incredible time of progress for the telescope. All 4 science instruments are here, and their representatives are here in the front. All of the 18 flight mirrors arrived. We had the first test of the integrated instrument module last year, and as I mentioned, we completed the critical design review. It's being assembled as we speak, and now, if we're going to try and do a virtual tour with Paul Geithner, who's the Deputy Project Manager, we'll have an opportunity for the people up here to ask some questions. So, Paul, can you hear me? And are you ready to start?
Chris, I can hear you.
Great. Everything is working, even in the rain. So, Paul, go ahead and take us on a tour of the facility. And I might note, this is the same facility that for many years was used to develop the servicing hardware for the Hubble Space Telescope. So it's moving on to its next generation. Paul, it's all yours.
Thank you, Chris, and good morning. I'm coming to you from the largest clean room of its kind in the world, the Spacecraft Systems Development Integration Facility. The air in here is about 100 to 1,000 times cleaner than the air you're in right now. And it's like an operating room, and this is basically the birthing room for the James Webb Space Telescope. So with Mike McClare here, we're going to go ahead and review some of the hardware that's in here. First, I want to show you the NearCam. That stands for Near Thread Camera. This is the workhorse. This will be the workhorse of the telescope. It's going to take stunning images of things never before seen. It also functions as the tool we use to align and fine-tune the telescope when it's in space. Even though it's very clean in here, this has a protective anti-static bag over it. Even cleaner while it's sitting here. So this is our #1 instrument. It's from the University of Arizona and Lockheed. And we'll come over here with Mike to look at the next instrument, which is from our partners, the European Space Agency. And it is the NIRSPEC, which stands for Near Infrared Spectrometer. This is a very powerful spectrograph. What that does is it's going to spread light into its constituent colors, kind of like a prism does with light or raindrops do with light to make a rainbow. It's going to spread light into its constituent colors, and that way scientists will be able to determine how fast objects are moving, and it will also tell them what they're made of, their chemical composition. So we'll be able to see what stars and galaxies are made of, and even perhaps detect the molecules that we know are associated with life in atmospheres around other planets, orbiting other stars. It's pretty exciting. And then over here, next we have, inside the instrument module itself, is the mid-infrared instrument, or MIRI, and it's the silver one on the side. This is both an imager and a spectrograph, and it's unique in that it takes images and spectra at the longest infrared wavelengths. This will be a very powerful tool for confirming if an object is one of the very first in the universe or not, and it will be very powerful for doing studying star and planet formation. And then last among the 4 instruments is the FGS nearest, that's fine guidance sensor, near infrared imaging slitless spectrograph. It's a mouthful. That is from Canada, from the Canadian Space Agency, our other international partner, and it serves a critical function. It will enable the telescope to point extremely precisely on its targets. Again, it's from Canada, and I neglected to say MIRI is from a partnership of Europe and the Jet Propulsion Laboratory. So there are our 4 instruments and the science instrument module itself, which was designed and assembled by Goddard people here at Goddard. It's a marvelous structure. It's the heart of the observatory. So now I'd like to walk over to show you a primary mirror segment. So on the way, I want to talk about why infrared. Well, if you want to see visible light from the very first stars and galaxies to illuminate the universe, you actually need an infrared telescope today to see it. And that's because the ultraviolet and visible light emitted by those very first objects has actually been stretched into longer wavelengths of infrared light by the expansion of space itself since that early epoch. And so that's why James Webb is an infrared telescope. Mike's going to follow me up the stairs. So since it's infrared we can't see with our eyes, but it's heat radiation. We feel it as heat. And so for a telescope to be very sensitive, an infrared telescope to be very sensitive, it has to be extremely cold, so it's not looking at its own infrared light. So here is a mirror segment. This is one of the 18 mirror segments that will make up the primary mirror. This is the first one we made. It's a flight spare, and all the flight ones are just like it. As you can see, it's six-sided, hexagonal shaped, and it's made of beryllium, which is an extremely lightweight and stiff metal that is stable at the cryogenic temperatures that the telescope and the instruments will operate at. It's coated in gold to optimize its reflectivity in the infrared. This was made by, or the construction of these mirrors was led by Ball Aerospace under subcontract to Northrop Grumman. One thing interesting about these mirrors, this is about 1.4 meters in diameter. If you scaled this up by a factor of 2 million, so it's the same size as the continental United States, this thing's so smooth that the average altitude difference between peaks and valleys would be only about 2 inches. That's how smooth this mirror is. 18 of them make up the primary mirror. And over here is the robot arm that we will use to place all 18 segments onto the telescope structure. I'm actually standing on what we call the ambient optical assembly stand, which is a massive precision structure for assembling the telescope. This is a pretty neat robot arm. It will place each of the 18 segments into what we call the backplane. It's a structure that will hold the mirrors, and this is right here is an engineering model we use to validate our design of the structure. It has 3 out of the 18 cells on it, and we were practicing putting mirror segments into this before the flight structure shows up. So that's what I have to show you right now. Lastly, if you want to see where all the mirror segments are, up on that mezzanine, looks a little bit like the nursery from the movie Alien. That's where all those cool looking shipping containers are where the flight mirrors are. So, just in closing, some of the greatest discoveries from Hubble were basically answers to questions no one even thought to ask. And James Webb Space Telescope, with its tremendous capabilities, will really be something. Whenever we look at nature with new and powerful capabilities, we always discover amazing things. This is the promise of the James Webb Space Telescope.
Okay, thank you, Paul. You can see, hopefully you heard you got some rounding applause there for a great tour. Someday we'll let people see your face. And now I'd like to give Senator Mikulski and Administrator Bolden an opportunity to ask you some questions.
Great. No, seriously, I'm stoked.
I have to teach you when you're on microphone, Paul.
I'm stoked. I'm stoked. I really am. Okay.
Hey there, Paul. How are you feeling?
I'm feeling
you feel
great.
like kind of the Broncos defensive line up there now? Here's my question. Paraphrasing over the Ronald Reagan quote of trust but verify, ours is test but verify. We all remember the white knuckle experience of the Hubble, that after it got up, it needed to be repaired, the famous mirror, the largest, most expensive contact lens in world history. My question to you, as we look forward to the testing and verifying, what lessons learned from the Hubble experience will be applied here so that when we launch the James Webb in 2018, it really is error-free?
One is...
Do you feel like the first 30 seconds of that game?
No,
Paul, your audio dropped out.
Oh, can you hear me now?
Yeah, we can hear you.
All right. No, it's a great question, of course. There's really two things. One is all our testing is being done completely independently from the manufacturing. So the tools we use to test the instruments, the optics, they are completely separate from the instruments that were used to, and the tools used to build them. And that was the fatal flaw with Hubble's primary mirror, was the same tool was used to guide its polishing. That it was later used also to verify its figure. Well, if you set it up wrong, you're still going to get a right answer, or you think you get a right answer. So what we've done here is all our tooling is for manufacture, and our tooling for verification are separate. And then the second thing is independent review. We have rigorous and expert independent review of all our testing procedures, in particular our optical work, with a panel of esteemed engineers and scientists. And that rigorous independent review was really useful. It kept us from making any mistakes. So, and then there's really one more thing, I guess, if you could add a third thing, and that's adjustability. You know, the fact that this telescope is deployable means we need to be able to adjust it so we can get it all lined up. And that adjustability that we need for deployment also will help us out in making sure that we can make the telescope line it up and make it good.
Okay, thanks, Paul. And now it's my privilege to introduce our administrator, Charlie Bolden. You all know him. He's been a great supporter of the James Webb Space Telescope through its development. And of course, you know, he and John actually visited Hubble. Charlie delivered it, John fixed it, and improved it, and Senator Mikulski paid for it. So we have the Trioca that made Hubble a great success, and of course many of you worked on Hubble as well, and now you're making JWST a great success as well. So Charlie?
Thanks very much, Chris. And I will be very brief because I think everybody wants to hear from Senator Mikulski. But it is a pleasure for me to be here with Senator Mikulski this morning, particularly because it gives us an opportunity to brag, if you will, about the progress that has been made with JWST. And that is incredible progress. You know, unless you go back to the beginning of something, bad days, dark days, that Senator Mikulski sort of implied in her comments about Hubble, then you don't have a way to appreciate where you are today. And 5 years ago, Senator Mikulski and I, it was not pleasant, to put it mildly, because I had to go in and explain to her that I had not done a very good job of stewardship of the James Webb Space Telescope as the incoming NASA administrator. But I pledged to her that we would fix it. And one of the reasons, you know, that this team is here today is because of that promise we made to her. On a lighter side, Eric's sitting down here. People back at NASA headquarters are relaxing this morning that are in our morning workout group, because if Eric's not there, we're not doing T25 or any of that other crazy stuff. So it's good to be here. I really believe that, like the other great observatories that are operating today, whether you're talking about Hubble, Chandra, or Spitzer, JWST will revolutionize our understanding of the universe. And Paul talked about one thing. If I had asked a question, it would have been, I am very, very hopeful that what Paul talked about with NIRSPEC, for example, that we can look into the atmosphere of some of these planets that we are now discovering, you know, with other instruments that we call exoplanets, particularly those that seem to be very similar to Earth. That we can look into the atmosphere of these planets with James Webb, and just like you teach a kid today what the percentage of nitrogen or oxygen or hydrogen or other gases in our atmosphere are and why that sustains life, we'll be able to do that with James Webb in planets that are, I mean, they were inconceivable 10 years ago. I mean, just think about it. Millions of them potentially. So I think that's the promise of James Webb, and I think that is something that there's probably not many people who recognize that outside of this room better than Senator Mikulski. And I think that's the reason that she was so tough on us and so demanding that we get it right. The team has worked through the early challenges, and as Chris said and Paul said, we're now delivering what we think is the best product possible. You should all be proud of the work that you continue to do, not just the work that has been done, because past is prologue. What counts from here on out is how we perform from here till we never cross the finish line, but until we get to the first products from JWST about an exoplanet. So I am really, really proud of this team and what we've done. As Chris has said, the 4 science instruments are complete. They're all here at Goddard right now, waiting for assembly. All the mirror segments are also complete and have been delivered. The backplane, and I wish I knew more about it, because that is the consummate in new technology. That was a technology that we did not have, and really without it, my understanding is James Webb would not be the instrument that we expect it will be, because we needed a stable backplane on which all these segments could sit and be adjusted the way that Paul talked about in response to your question about, you know, testing and everything else. Not only are we going to test and test hard here on Earth, but when we get it in space, we can actually make adjustments with it because of this new technology backplane on which these 18 segments sit, and we can adjust it real time if we have to. So that's incredible. It is an absolutely impressive piece of engineering, and it includes new technologies that make this spacecraft unlike any other we've ever developed before. And the good news, the really good news, is that we're on track for a planned launch in 2018. And that's great news. We've got cushion in our schedule, and we're hanging in there in cost, so we're doing, I think, pretty well. I want to thank Senator Mikulski. I want to thank you personally for being tough on us and for continuing to be tough, because it's sort of like raising your kids. You know, you can give them everything they want. You can try to be easy on them, but there is nothing like tough love. And I kind of describe that as Senator Mikulski's approach to us. It's been tough love, and she continues to hold our feet to the fire, and I know as long as she does that, we will try not to disappoint. We wouldn't be here today if she hadn't championed this critical capability for NASA. No question, none whatsoever. So anybody who thinks we would, you got another thought coming. We would not be sitting in this room today talking about JWST had it not been for her. I know she understands just how important it is to continue to push the boundaries of what we can do in space. With her support, Congress has passed an appropriations bill that reaffirms support for the bipartisan space exploration plan agreed to back in 2010 by the President and the Congress. Again, she's holding our feet to the fire. She said, okay, this is what you said you're going to do back in 2010. This is what the President put his signature on, and I'm holding you to it. It provides funding for the President's plan to return American space launches to the U.S., as well as groundbreaking scientific discoveries, game-changing technologies, and cutting-edge research into cleaner and quieter airplanes. We're doing all that, and we're doing it because of the support that she has continued to give us. The bill keeps NASA's deep space exploration program on track and will continue to spur American innovation and keep the U.S. the world leader in space exploration, as I continually tell people like Frank Moring, who's sitting out here, and others, and one of these days they're going to believe me, that we are the world's best, and we are still the world's leader when it comes to space exploration and scientific discovery. And I think we owe a lot of that to the lady who's sitting to my right, and I'm going to now ask to come to the podium. So it gives me great pleasure to introduce a great friend to NASA and to the Goddard Space Flight Center, Senator Barbara Mikulski. Madam Chairman.
Thank you, Director Bolden and Administrator Bolden, and to all of you. First of all, I'm just glad to be back at Goddard once again and to say hello to all of the wonderful men and women who work here at NASA Goddard, the civil servants, the contractors, all of the people here, over 10,000 people, scientists, engineers, our very own in-house Nobel Prize winner. I'm so proud of Goddard. Every day in every way, you lead the way in earth science, helping us understand the earth itself, its climate, and all the great science research that Goddard does. And we've had a very successful year, like at Wallops, where we've actually had an unmanned crew, an unmanned commercial vehicle go take cargo up to the space station, and our continued work with Hubble, space servicing, all the wonderful things you do. And now today, the delivery of the parts, all of the component parts, to really actually build the James Webb telescope. I see this as kind of like Lagos meets NASA and all of these parts being put together. But I have a great deal of confidence in what's going to happen here, that it will be assembled, then tested, then its major route all the way to French Guiana in 2018 for its launch. Now, Administrator Bolden has talked about how tough I am. Friends, I'm not the one that's tough on you. The Tea Party's tough on you. I've saved you from the Tea Party. My firmness in getting the right information to keep on budget line saved you. It was not me being tough. It was them seeking quick fixes to cut the budget. And James Webb Telescope, at the cost of $8 billion, was standing out there like in an orange jumpsuit, waiting to be cut because of some, really, quite frankly, the lack of stewardship and oversight at NASA. But we've now righted that ship with the Cassini report, the fact that we have a actual game plan for making sure the project is completed on time. We were able to do that. But just remember, it's not me. Let's not make it personal. The fact is that me was to make sure you got to do what you do. My job is to help you be you. My job was also to try to protect the overall NASA appropriations. And I am so pleased that this year, and on January 20th, we passed the fiscal appropriations for the funding for the United States government for fiscal 14. It was bipartisan, it was bicameral, it was the first time in several years that we actually got it done. And that means to everybody here who works at NASA, both at Goddard and all of our wonderful facilities, there will be no more government shutdowns. There will be no more furloughs. And for fiscal 14 and 15, we can guarantee that there will be no more sequesters. That's why I was firm, so that I could fight for you, and at the very end, we could deliver for you. Aren't you excited about that? We worked together, and it wasn't easy, I can assure you that. You know, Senator Patty Murray and Paul Ryan did a great budget showing that you can compromise without capitulating on principle. Those two worked and led the way. We in Maryland had the very able help of Chris Van Hollen, who was the vice chair of the Budget Committee. They gave us the framework. They were able to cancel sequester. Then it came to appropriations. Senator Richard Shelby, another devoted advocate of America's space program, and I went to work with the House. They said it couldn't be done. We'll pass some things like defense, but the others will put into a CR, a continuing resolution that would have frozen you at 2013 post-sequester levels. That would have been a disaster, no matter how able the administration, no matter how insistent the oversight, no matter how faithful the employees, it still would have been so Spartan and so skimpy that we would not have been able to do what we needed to do. But we were able to go to work, and we did show that we could compromise on certain line items, even on certain riders. I faced 134 poison pill riders when I went into negotiation, but at the end, we were able to get it done. And what does getting it done mean? We will fund NASA at $17.65 billion. The James Webb will get $658 million, $23 million more than fiscal 13. But most of all, for the NASA employees and for the contractors, we won't face sequester. We will actually have certainty in the budget so that we can plan, we can test, and we can execute. And we did that because we are so proud of you. For this we know that 2013 was indeed a tumultuous year. 97% of NASA's workforce went through furloughs, halting research projects, causing delays in testing. Now we feel that we are on track. We have so much faith in you, and that's how we would round it. We have the right stuff. So much is said about America's exceptionalism. Our exceptionalism lies in science, technology, discovery. That's who we are. It's not only financial entrepreneurship, which is, yes, the hallmark of our country, but it's intellectual entrepreneurship and working with great partners like one of the most wonderful neighbors you could have in the world, the Canadians. And I think the Canadians deserve an extra round of applause. So to our Space Mountie today, we say hello to you. So I'm happy to be here at NASA today because this is the latest piece of the puzzle, bringing important instruments and mirrors to Goddard. When completed, this new telescope will absolutely secure our lead in astronomy, I think, for the next 50 years, inspiring generations of stargazers and scientists. For all the groundbreaking that Hubble did, for the rewriting of all the scientific textbooks that Hubble did, the fact is that James Webb, with its 18 high-tech mirrors and 4 advanced scientific instruments, will even be far more superior. And even 50 and 100 years from now, they'll be writing books about what the Hubble did and what James Webb does. We're so very proud of what is going to happen here. So much has happened already. The fact that all of the parts are here, that it's actually happening, that we actually saw on our virtual tour, the whole process going the next step, is why we work so hard. And I said when I was at the Space Telescope Institute, what is so phenomenal about what we will do and working with our international partners is that a lot of our information and our knowledge will give away. A big nation can build a telescope. A rich nation can build a telescope. But it's only a great nation that shares that information, that knowledge, that know-how with the world. This is why I'm so proud of what you do and how the United States of America will lead the way. But in leading the way, we do it with others. And I believe that we'll look back on this milestone as one of the great benchmarks. So good luck to all of you who are going to test, verify, and move it on, and may the force continue to be with you.
Well, you know, it's always difficult to follow Charlie, but it's impossible to follow Senator Mikulski. Um, uh, I'll be closing this out and give some logistics in a moment, but before I do that, I really want to thank Administrator Bolden and Senator Mikulski for being with us here today. As you can see and as you heard, we have two fantastic supporters in the highest places in government, and really we couldn't do it without them. You know, I've been in this job for 2 years, and I've been in another job for a little longer than that with Charlie, and have had the opportunity to watch, you know, how the government works and how this center works. And I have to tell you, this center is one of the best there is. I know we can build this telescope. I know we'll do a great job, and I know with the support that we have from Senator Mikulski that we have all the support that we need to make it happen if we do our job. So we'll continue to do our job, Senator, and we'll make you a great telescope, and we'll keep that centuries-long history of Hubble and add JWST to it. So now I have to do logistics, and this is where I have to read again, and I'm not very good at reading, okay? So what we're going to do is the people in the front row will come up here, and we'll do a photo op with the senator and the administrator. The press will take you into the back, and after the photo op, we'll come back and meet with you to do some opportunities there to ask questions of us. So that should take just a few minutes. So with that, thank you all very much for being here today, and go off and enjoy the day. Stay as dry as you can, and hopefully the snow doesn't come.